Black holes are fascinating cosmic objects that have captured the imagination of scientists and the public alike. Here are some key facts and secrets about black holes. What is a black hole? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. It is created when a massive star collapses in on itself. Types of black holes. There are 3 types of black holes: stellar, intermediate, and supermassive. Stellar black holes are formed from the collapse of a single massive star, while intermediate black holes are believed to be the result of multiple stellar black holes merging together. Supermassive black holes are found at the center of most galaxies, including our own Milky Way. Event horizon. The event horizon is the boundary around a black hole beyond which nothing can escape. It is the point of no return and marks the boundary of the black hole's gravitational pull. Spaghettification. The gravitational forces near a black hole are so strong that they can stretch an object into a long, thin shape like spaghetti. This process is called spaghettification and occurs as objects get closer to the event horizon. Time dilation. Time moves slower near a black hole due to the strong gravitational forces. This phenomenon is known as time dilation, and it is an important aspect of Einstein's theory of relativity. Black holes can emit radiation. Despite their name, black holes can emit radiation. This is known as Hawking radiation, named after physicist Stephen Hawking, who first predicted its existence. Hawking radiation is a result of the quantum effects near the event horizon, and it causes black holes to slowly evaporate over time. No information loss. The information about matter that falls into a black hole is not lost forever. According to the holographic principle, the information is stored on the event horizon in the form of a 2-dimensional image. Black holes can merge. When 2 black holes get close enough, they can merge together to form a single, more massive black hole. These mergers are some of the most energetic events in the universe and can produce gravitational waves that can be detected on Earth. Unknown interiors. The interior of a black hole is still a mystery. General relativity predicts that the singularity at the center of a black hole is infinitely dense and has no size, but this prediction is based on the assumption that quantum mechanics doesn't apply to gravity. Scientists are still working on a theory that reconciles these 2 theories. Supermassive black holes. Supermassive black holes are believed to be at the center of most galaxies, including our own Milky Way. Their role in galaxy formation and evolution is still being studied, but it is clear that they play a crucial role in shaping the structure of galaxies.